tour at Hannover Messe, huh? Are you excited or exhausted?
Excited, of course. I mean, look at this.
Yeah, I mean, this is a big buzz. I have to introduce, for the ones who don't know him yet, Lev Lebaredian. He is a frequent speaker at our stages. 2 years ago, you were at Hannover Messe the first time with Siemens, and since then, you did not miss a chance to present on our stages and talk about the great joint collaborations we have. You're the Vice President Omniverse and Simulation at NVIDIA. And we have Rainer Brehm here with us. He definitely is the one who made digital twins learn how to dance. He knows what factory automation is about, and he's the COO of Siemens Digital Industries and is responsible for our automation business within Siemens. CTO, as a matter of fact, excuse me, Rainer, but the OO is in there as well. So let me dive in here. Rainer, we have already seen AI applications for quite a while in industry. What fundamentally is different now that makes autonomous production real?
Well, no, we are handling with AI since decades. But in the past, AI was very much on the analytic side. So we analyze things or optimize things like quality inspection like that. But now we're moving from the analytic phase into the assistant phase. We yesterday launched our Eigen engineering agent, which is assisting or already acting now. And I think now the acting piece comes into it. And when we talk about autonomous production, AI-powered autonomous production, the acting piece is a very, very important one. But acting means really acting in the real environment. And that, I think, is a big game changer, which we are working now and will become more and more real.
Ref, when we say AI changes things, when AI leaves the digital world and it enters the factories with physical AI, what actually do we have different from what it was before?
And essentially, what Rainer was saying, how we've been using AI up till now is to analyze, to help us get insight into information that's naturally digital. The AI that we've had and what we're mostly using today is about the knowledge realm, which is encoded in the digital realm. What we're in the process of doing now is taking this capability, taking this intelligence out of the digital realm and giving it a physical form, giving the AI a body so it can act out in the physical world. This is a really monumental shift because it allows us to apply this computing technology that's on this amazing exponential curve of growth, not just to information, but to all the things that we do in the physical world. If you look at the global markets, about $5 trillion of the global markets are information technology. This is largely where the computing world, companies like NVIDIA have played in. But as we apply computing to the physical world, the $100 trillion of physical industries can now benefit from the exponential growth of computing.
Which is a big number, that's for sure. And when you say it's so easy, we're talking about real big numbers here. So talking about what was possible on the shop floor and what's possible now with all this new technology, what wasn't possible before, Rainer.
I mean, what Rev just said, there's a 100 trillion market, which is somehow in the industry. And the question is how you make this 100 trillion market more productive. And I think with the way when automation was always one main lever to get productivity into factories, into industry. But the way how you automate comes to a certain limit because currently automation is very much writing your code for the automation controller, the PLC, where Siemens is market leader, and it's acting. But if something else comes up which is unknown, the machine stops, so you cannot automate it anymore. Or if you have smaller lot sizes or need flexible tasks, automation is not good enough from a technology because it's made for mass production. So you don't have a good return of invest if you want to automate, I don't know, a lot size of 10, you better do it manual because, writing a program for a lot size of 10 doesn't really make sense. You could do it, but bad return of invest, so you don't do it. But now the question is, if we are not having a rule-based automation where I need to tell the system exactly what to do and how to do it, we go to a goal-based automation system where I only tell, do this, and it can be done for a lot size of 10, and this can be done for a lot size of 1,000 or a lot size of 1. That makes a big difference. But how you get there, that an automation system is smart enough to act flexible on a situation which was not pre-considered when it was engineered upfront. And now AI comes into play. So if we bring AI out of the digital world in the physical world and we embed it into our machines, into robots, into automation system, then the system gets smart enough. So you don't need to tell the system how to do things. You only tell the system what needs to be done. And that what needs to be done is executed by the system autonomously. And that's the big shift. And if you do this, then I strongly believe we're on the next S-curve of productivity. And productivity on a 100 trillion market, that's a big, big thing. And now we as partner, NVIDIA and Siemens, we want to bring this productivity to our customer that they benefit out of that.
So when you say tasks which can be done, is it like packaging or loading, or you have some examples?
If you go to a factory today, there are many factory workers and look what they do. And exactly, they're moving pieces from A to B. They unpack things, they pack things end of line. So those aspects, or they're doing maybe engineering tasks in the factory, a scheduling of what you produce next. But those tasks are still be done, and the question is, can we automate more of those tasks?
And it's not just physical tasks, also like you mentioned, data centers, topics like you think of huge number of wires to be handled in data centers.
A data center, NVIDIA calls it, and I like that, a data center is an AI factory. So now if you consider a data center as a factory, yes, also in a data center, absolutely. What I was meaning was more kind of, I need to produce a batch, and now I do a production planning. And that production planning currently is also a manual work, but it can also be automated in the future by agents, for example.
Okay, now, next question. What else does it take to move towards an AI-powered automotive production? Autonomous production, excuse me.
Well, in order to build these machines that can see, that can understand their environment, that can operate and act within these environments and do this well and do it safely, we have to create a brain for the robots themselves. The brain has to be capable of making the understanding of the world and making a plan and actually controlling the systems to do that. How we build these brains is actually very similar to how we train humans and animals. When a baby is born into this world, it doesn't know how to see yet. It's something it has to learn. It learns depth perception. It learns color. When the baby doesn't know how to operate its body, it learns how to do that by doing random things, doing some science experiments, breaking things, throwing things, until it learns how to pick up a cup and drink properly without breaking things. We train our humans on operating complex machinery like airplanes by first putting them in a simulator. We have them fly for hundreds and thousands of hours in simulation, doing in situations that are unlikely to happen in the real world, but if they do happen, are very dangerous situations. So we want them to have experience doing that. So the way we have to train these AIs is essentially by reconstructing the physical world in a simulation where they can go learn how to behave, how to operate, how to understand things in the physical world in a safe place before we deploy them. Now, the problem that we have is, although we have all of the technologies to simulate many aspects of the physical world, building these simulations, building the worlds that we simulate and making them accurate is actually very human intensive itself, similar to the task we're talking about doing in a factory. And so that's always been prohibitive in terms of the amount of time and cost for us to build a simulation to actually do this. But fortunately, this new technology that we're building, these AIs that can understand the physical world, are the same AIs we can use to help us build the simulated worlds that we then use to go train the AIs themselves to operate out here. So this is the big change.
I like the comparison to learning how humans learn things, but some learn fast and some never learn at all. So I think the AI definitely is the easier to handle part here, right? In comparison.
There are things that humans are always going to be better at, as far as making value judgments, deciding what is worth doing with our limited resources, what is going to give us the most value. That is something only a human can do, and so we will always be better at it. But there are things that machines, they've been superhuman at doing many things for a long time. We have industrial robots that can lift whole cars and move them. No human could do that. There's no problem between us working with machines that can do some things better than us.
It's still the guts feeling, which is something which we as humans have, but it's definitely the faster learning aspect with AI. Now, in regards of this moving towards an AI-powered autonomous production, Rainer, what's the Siemens scope in here?
I mean, building on what Rev said, he talked about the brain, and the brain need to be trained. So I think training the brain, we use very much also Omniverse from NVIDIA to train it, but we have as Siemens comprehensive digital twins. So having this kind of information of a machine and the behavior of the machine, using this kind of physical data, which we already design, and using that, and using them with Omniverse, also creating then photorealistic training data sets, which we need to train the brain. This is one topic where Siemens and NVIDIA is working very close together. So how we get a very intelligent brain, number one. Number two, then you have the brain and need to deploy it. It needs to run in a real environment, because this is now where the brain meets the physics. And in the physics, Siemens is providing a lot of automation equipment, like our controllers, like our PLC, so all the connected automation, the embedded compute, the connectivity to all the different sensors, but also maybe data which are coming out of the process. So our goal is then to take this brain and embed it to make really real-world actions. That's the second path we are working together. And
where are we at Siemens at this journey, looking into our sites and production facilities, Rainer?
Well, I mean, that is on the CES in January, we announced we're working especially in that area. I mean, we're working in a lot of areas together. We're just focusing now on that area, how we really move to an autonomous AI-driven production. And we said, let's act as a customer zero at Siemens. And we have our factory in Erlangen. And we want to make them the first AI-powered autonomous production. And here we're working together to really enable to move manual work into automation. And this is a highly automated factory, which is a world economic digital lighthouse, but still we have a lot of manual work. And one topic is, and this is very representative for a lot of manufacturing, end of line packaging, which is normally manual work. So we do it as a customer zero. In this case, maybe we have a small video where we show how this is done. So this plastic bag, currently a human takes and put in the box. And in the future, this should be done by a machine. In this case, it are 2 robot arms. The brain to do this, we train together with NVIDIA, also using Omniverse, and we embed it into the automation system that it can be done. And it's an interesting use case because it's not only doing a one task. You see here the robot arm is correcting something. Something is not in the box, so it's correcting it. So really it understands the situation and is acting accordingly. And that is one of the use cases. And what we do together now, we say, what are the use cases with the best return of invest? And we work on those use cases as customer zero, but with a clear goal to scale it globally to our customers.
Okay. So what's NVIDIA's role in here when we see all that? You said you've been working on that together?
And NVIDIA's position in general in the world is to build computers. We build the most advanced computers to solve the hardest problems. Problems that are practically impossible, we make possible. For physical AI, and for what we're talking about here, you need three kinds of computers. You need the computer that's actually driving the robot. That's the brain, the software that is the brain of the robot runs on. We build those computers in the software stack for that. But before you can use that computer, you need the AI factory that produces the brain. So we also produce that and all the software stacks there. But to use that AI factory, you have to feed it with the raw material into the AI factory, which is the data about the physical world. And for that, we use a simulation computer, the Omniverse computer, to generate the data that feeds into the AI factory. We build all three of those, but by itself, this is just raw technology. We can't actually take this to market and make solutions and applications for others. And so our position here with Siemens is to couple our technologies, to infuse our technologies into Siemens's offerings, to actually make solutions and applications that solve real problems in industry. We do the hard computer science stuff, and Siemens maps our computer science and our computers to the physical world, solving industry's problems. Together, it's a perfect match.
Perfect match, and it seems you have it under control, but what's the toughest problem you haven't solved yet?
I mean, industry shop floor means high reliability, and we don't talk about 80%. We need a close to 100% reliability. It needs to be secure. It needs to be easy to use also for the operator when it's really running. I think that's a very big element. At the end, we don't do this as a proof of concept. We want to have a return of invest. So we also need to reach a cost position where it makes sense to put it into place. I think these are the 4 areas we're working on.
Okay.
Yeah, and I think at the core of solving all those problems, we need to have more simulation. We need to make it easy to create simulations of all of the things that we're going to deploy to ensure that we build really good AI, physical AI, really good robot brains that actually are robust, that work well in every situation, that are safe and efficient. But to build those simulations has always been too hard. It requires experts that we have very few of in the world to even set up the simulations to begin with. For the first time, we now have a technology that actually removes that bottleneck for us. These AI agents, the coding agents that have arrived, that are basically allowing all of us to have these superhuman abilities to develop software, are the exact same. It's the same technology we need to create these simulation experts that will help us build the simulations and move forward. So this has been the biggest challenge, but we now have the solution to it, and it's time for us to apply it.
Perfect. And since time's almost up, I have one more question to you. Since we're talking about the future and innovation, when we talk about AI, I think thinking in a future of 5 to 10 years and factory automation, can you even imagine what that's going to look like? We talked about it yesterday with AI. Things will change in 6 months tremendously. So what's your envision?
I mean, Ref just said it. I think the possibility of agents and always on agents, acting agents, is not at all yet arrived here. So if we move that further, we really move step to our AI-powered autonomous production. And the good thing is every step creating customer value. Not like self-driving cars. You either drive it autonomously or not. Every step creates customer value. Agents gonna be, and the workflow of agents will be the next big step.
And your point of view, Raf?
Yeah, our factories, our warehouses, the 10 million plus factories in the world are all going to have autonomous systems. We're going to have the factory and the warehouse itself be a robot that's watching all of the robots that are operating inside. We're going to have AMRs moving material around in these factories, arms, humanoids. Every form factor of robot you can imagine in 10 years is going to be there. We're going to have AIs dispatching work to other AIs, and all of them can embody themselves into physical form at will. It's going to be pretty amazing.
Pretty amazing, and we just are the ones to give commands and book a flight to Brazil and enjoy our time there, as we don't have really physical work anymore ourselves, which we have to do. We just have to give commands. Thank you so much.